We'll start in 2 minutes. Thanks for coming. Thank you all for coming for the entire weekend. The entire week. Hope everybody got value, and I know I did. Got a couple of announcements before we get started. The pin drives are ready at the desk just outside the door, and please don't forget to mark on there to check off that you have taken your drive. And if you have any more material, you can get it to Andreas for the second printing, which will occur at the conference next year, and to put the data online.
I'll actually do a second printing in a couple, 3 weeks.
Oh, we'll do the second printing in 2 to 3 weeks. So great. So you have an opportunity. If you have any supplemental material, I know I do. Okay. Our first speakers today, Ganesh Koru is a professor at the Department of Information Systems at the University of Maryland, Baltimore County, and his student, Abir Rahman, who is also studying information systems at the University of Maryland, and they're going to speak this morning on the development of the Home Care Quality Toolkit. Please give them a round of applause.
Thank you. First of all, I'd like to start by saying a big thank you to everyone who contributed to the organization of the conference, presented their work, or attended. So it has been a great event for us, very informative and wonderful exchange of ideas. So today we'll talk about a research project. So I wanted to basically say two things up front. This is an applied research project, so this is more about application than some of the language constructs that we've been hearing about throughout the conference. But I think it's relevant because we would like Tcl to be used more frequently and serve people's needs. And the second thing I would like to mention is that this is an ongoing research activity. For example, you'll hear that in the objectives, you're going to talk about getting information from the healthcare administrators, but we are starting with some data collection from students to start up. So this is an ongoing work. So this is the outline of our presentation. I'll talk about the background, and then I'll turn it over to Abir. So he's going to continue to the presentation to talk about objectives, methods, results, and limitations of what we do, some discussion and current status of our work. So how many of you have heard about home care? So how many of you have received home care or have known somebody who received home care? Okay, so we have some people. So actually statistics show that 70% of the US population somehow either receive home care or know someone who receives home care. So this is an off-site form of care provided to the elderly patients. So they need to be homebound, and it is approved by a physician or nurse practitioner in some states. So it basically involves what happens after people are discharged from the hospital. So it is provided by an interdisciplinary team of professionals that include skilled nurses, speech therapists, physical therapists, occupational therapists, sometimes even include social workers when it's necessary. And the importance is that as as there are medical advancements, people live longer, and currently not only the size of the 65 and above increases, the percentage is also increasing. So by 2030, it is expected that 1/5 of everybody in the US will be 65 and above, almost 1/5. So home care will be critical for cost containment because we wouldn't want the patients to be readmitted to the hospital. Hospital care is very expensive. You might have heard about this. So the main payer in this area is the Centers for Medicare and Medicaid Services, particularly for the elderly patients. It's the Medicare program. And because the federal government pays for the care, they expect that there is quality. So the quality data comes from an assessment tool called outcome-based quality, outcome and assessment information system. So this is basically a questionnaire. It's a survey. CMS takes the data and aggregates that to the agency level and then publishes the data. It's actually great because this compare program, it's not only for home care, it's not called home care compare in our case, but there's also hospital compare, nursing home compare. So it allows you to go to that website and compare the quality of care provided by different providers in your area. And so many patients or families may not know about this, but it's actually quite useful. But of course, it would require you to look up the data and do some analysis on the data. So Home Health Compare repository contains these quality measures to be used for what is known as QAPI, Quality and Performance Improvement Initiatives. Actually, CMS requires home health agencies to have initiatives in their organizations to improve the quality of care. So what are those measures? For example, timely start of care, emergency room visit rates for the patients, and admission rates for the patients. So there are a number of others, so these are just examples. But there are challenges with utilizing home health care data because it is increasing in volume and complexity. Of course, when we talk about data size, the immediate question, how big is big? So we are not talking about very big data, of course, but it is still becoming more difficult to put it in usual office tools and analyze it. And also there are, even though it is published by CMS, there are quality problems with the data. So for example, we recently found that a value in 200s was in the 201 was in the records, but actually these are rates. So they should be, any value should be between 0 and 100. There are many missing values. So also the users of the data need to pre-process the data to be able to use it. So there is currently a lack of understanding about how quality professionals, quality and performance improvement professionals in home health agencies would like to summarize, visualize, and compare performance of their organization using this the data in the repository. So for example, would they want to do some kind of time series visualizations? What kind of statistics would they want to see? There are no studies published about this, and there's also lack of evidence-based, useful and usable tools for quality professionals. So the objectives for this study was basically to understand how quality experts would like to summarize, visualize, and compare HHC data through software prototyping, and also understanding the usability, which is ease of use, of the resulting prototype through usability evaluation techniques. So why do we focus on these two aspects, usableness and usability? So many studies and models such as technology acceptance model or variations of technology acceptance model repeatedly show that people have to perceive something useful and then usable, and then you can address some of the other issues as well so that the technology can be adopted. Of course, in this context, we are not talking about throwaway prototypes. There's going to be some functionality. So we want to show something functioning and then go from there. So I'll now turn it over to Abir to continue with the rest of the presentation.
So let's go with the methods overview. To achieve our two objectives, we took two methods. First, we have prototyping. To do prototyping, we adopted the iterative development approach because it provides us with the feedback and brainstorming opportunities for design and refinement of the product. And the initial prototype was designed based on the requirements that have been come up by the researchers themselves because we had tested from somewhere to build the prototype. And the prototype was developed using Tcl programming language. The GUI was developed with Tcl. And for database, we used SQLite3. And for plotting, we used GNU-plot. And for the usability evaluation, the initial deployment was done with the students because we didn't want to contaminate the small sample pool of sample we had of copy professionals in Maryland. And actually, the graduate level students are someone who will join to the workforce very soon, and they have some experience with working in enterprise level software, so they can provide us good usability feedback. And the initial improvements was done from the suggestions that have been provided by the students. And in the upcoming iteration, we will interview the co-op experts and implement their solutions. For the prototype development, we used the data from Home Care Compare database, here's the link. And the data includes the provider characteristics, the process outcome, and utilization measures. For that data pre-processing, we actually imported all the data into a SQL3 database, and we had to do some cleaning because there were empty cells, and as the professor said, there was 200 ones, which means there should be no value, and there were strings where should be an integer. So we had to clean them and replace them with null. And for the approach to development, we implemented a tab approach where the notebook of TTK was very useful. And the selection pane was kept fairly simple. We just used combo box, radio buttons, and buttons so that the user don't have any difficulty to choose the selections. And the visualization can be obtained based on any locality, provider, or provider group. By locality, we mean the user can select a particular state, city, state, or the national level. So they are not confined. And the provider, the users can create a group of provider, and they can store them into the database so that they can come back and reuse it. And for plotting, they can detach the plot and export them into PDF, SVG, or PNG. And to the usability evaluation, we used a system usability scale that is known as SAS commonly. And it is used because it's one of the most commonly used usability assessment approach across domain. And in SAS, there is a 10 5-point scale questionnaire from strongly disagree to strongly agree. Total SAS score from this 10 question can be result in 0 to 100. And if the score achieved is between 68 to 80.3, then we can say that the usability is good. And if the score is from 80.3 to 100, then it's excellent. And we implemented a think aloud protocol so that we can get some qualitative feedback from the users while using the software. Moreover, the questionnaire also had the option to provide usability improvement suggestion. And for hypothesis testing, our null hypothesis says that the agreeable, agree, and strongly agree will occur with 50% probability. That means there is either equal or less than average usability. And to reject that null hypothesis, we have to prove that the agreeable answer would occur with more than 50% of probability. And hypothesis test is done on each of the 10 questions. And to set the sample size, we did a power analysis where with a 35% effect size, 80% power and 5% significance level, we came up with the sample size of 11 people. And here are our 10 questions. So let's look at the result. Our tool. Our tool has 3 main features that are summary, benchmarking, and analytics. In summary, there is a descriptive statistics and a histogram. In benchmarking, the user can create groups and compare them over time. And in analytics, there is a scatter plot where the user can select 2 measures for X and Y axis and see how the agencies of a particular area is scattered in terms of those 2 measures. And a spider plot where the users can see for a particular time and a particular area how all the measures are summarized, and time series where the users will select a particular measure and see how the measure has been fluctuated over time. So let's look at our first feature, the summary. Here, to summarize, the user need to select a start year and a end year, and select a measure which they want to summarize. And from the locality, they can either select provider, provider group, or any of the localities. So we have selected a provider group, Baltimore, Washington area. In this group, all the home care provider agencies in Baltimore, Washington area is grouped. So here they will get a histogram, and on the top right hand corner they will get the summary information where the average rating of all the agencies in Baltimore or Washington area is provided, and also the average minimum, maximum, median, and standard deviation of the selected measure is provided. The second feature is benchmarking, where they can use the create new button to create groups. And after creating the groups, they can compare these groups over time. So for demonstration purposes, we have created 4 groups. These are actually a few of the largest groups in home health industry. These are BAYADA, MDCs, Zentiva. And for comparison, we selected the beta taught drugs measure. And here's the result. For this comparison, benchmarking comparison, we use box plot because from this plot they can easily understand the minimum, maximum, and median. And then we come to the our analysis feature. So in analysis, there are 3 different options to choose from: scatter plot, a spider plot, and the time series. To view a scatter plot, the user need to select 2 different measures for 2 different axes. That is, here we have selected the timely care for x-axis, and here emergency room visit for y-axis, and we have to select year segment. That is, here we have selected 2016 third segment and selected the area as Texas. And here we can see how scattered the agencies are for these 2 measures. And we can detail the plot and select the outlier agencies. We have blurred the outlier agencies because we don't want to show their names. And then we have a spider plot. Here the user have to choose the start year and year and choose the locality. Here we have again chosen Texas. And to show how these plots can be used, we generated 2 different plots and put them side by side. Here we have Texas and Maryland, and we can see that the beta bed in Texas is better than what is in Maryland. Again, the taught drugs is performing better in Texas compared to Maryland. And lastly, we have time series. In time series, the user have to again select a particular measure and select the start year and end year to see the time series. And we have selected the state Arkansas to see it. And we can see how the timely care performance has been fluctuated in Arkansas over time. And for usability assessment result, we got 91.59 in search score, which means this tool had excellent usability among the students. And with 99% confidence interval, we achieved 72.62, which is still very good. And for the search questions, the null hypothesis was strongly rejected in favor of the alternate hypothesis because only for one question the p-value was 0.03, which still meets our requirement, and the rest was much smaller, less than 0.001. And limitations, as we already said, that we have done this study with the students. And now actually we are conducting the interviews with the copy professionals. And data analytics is something that is really now confined into the among the researchers. So we actually need a tool that can provide usable and useful way of doing data analytics among the users who are not technically not that sound. So this tool can enable better comprehension and interpretation of data, and also support home care quality improvement through drawing improvement decisions. And plan status, we are actually now in the phase of interviewing the quality professionals, and we are continuously taking in their suggestions and doing improvements over the tool. Yeah, that's it. Thank you. Questions, suggestions?
Yeah, I've had some experience trying to get the general public to use software. We wrote a registration system for a folk festival. And one of the problems I always had is they love the screens, but then I would go back and figure out who actually gave me that clipboard worth of data that was so important. And I actually couldn't produce any data for the last 20 years because I had less than half of the things that were supposed to be entered. Do you guys have that problem with your data collection?
Yeah, I think we need to decide on who will be the users. So in this study, basically, we are talking about maybe a chief nurse or somebody who is really concerned about the quality of care in a home health agency. So these are actually people who end up playing with numbers somehow, but their backgrounds can vary. So we try to figure out which plots, visualizations will be useful to them, and how. Also, we want to make this easy to use. But yeah, it's a good point that we need to determine who the users are. I think it's more difficult for general public.
But your users are not entering data.
They are not entering data, but so that's also so CMS publishes data, but it comes late. So it's like I think 6 months to 9 months late. So we may actually enable some data entry features, because if they have data, more recent data, they can enter and see how well they perform. And this is because there's big pressure in the home care industry to perform right now. So in 9 states, CMS implemented value-based purchasing programs. So this means that some agencies are penalized for not performing well. So the money coming from the penalties, they go to a pool, and then it's distributed as rewards to the high-performing agencies. So there's also a lot of regulation changes. So the small players are kind of disappearing right now, and they are bought by the bigger players, and you end up with some entities having multiple agencies. So that's why we created groups actually, so that they can compare. If, for example, a provider wants to compare the performance of his group of agencies with another group of agencies, they can do that, and they may be spread over different states.
So I have 2 questions. One is, it looked like the scatter plot was generated with new plot.
Yes, new plot.
It was new plot. Okay. So was some of this generated? So what software was used to generate all the different visualizations?
So the plots charts, they all come from new plot.
They're all from new plot.
Mm-hmm.
Okay. And then table. Okay. And then I was curious about, because I also deliver software for users who don't always know exactly what they should be looking for in visualization. Have you thought about how to help the user decide, to guide them to what plots would be appropriate to look at, to help them figure, or because right now it looks like you're just saying, here are the different plots and you choose. I'm just wondering if you're doing anything about trying to help them sort of navigate all of that.
Mm-hmm. So we have some ideas about what they use, but I think I agree with you, as we go into details, we need to learn from them. So basically, it's going to be a semi-structured interview protocol, asking them like in what ways they are having challenges in understanding their own performance and comparing it with their peers. So I think asking about the challenges that they experience in doing something is going to be the key point, and like what types of challenges, because that's how we should derive the requirements, not just by asking what do you need, because you force people to think about what kind of problems they experience on a day-to-day basis, and even try to ask questions then about the root causes of those problems, because some problems may be just symptomatic and they may be results of some other problems. So we have a way of going about this. I can share that offline. So I would be happy to share the protocol with you as well.
Okay.
Well, Thank you very much.
Thank you.
Our next speaker is Cyan Ogilvie. He's the software architect at Ruby Lane, which is the world's largest curated marketplace for antiques, vintage, collectibles, fashion, fine art, and jewelry. Starting out with basic 10 Pascal and assembler, building 3D engines. He moved to Tcl in the late 90s, and he's since built, this kind of blows me away, he's built around 100 extensions. So please welcome Cyan Ogilvie.
Hopefully that will recognize it. It did it a little earlier. So maybe while I'm waiting for that, so I'm kind of a tool enthusiast. So what I'm talking about today is a fun new tool, or I intend to be, if I can get it to. Okay, back up. I apologize for this.
Something happened.
Yeah, I managed to get it on BGA. Okay, finally. So, I'm talking today on this thing called Serverless, Tcl, this AWS Lambda. So, what is this serverless thing? It's kind of what it's not. So, generally, if you were providing a service over the internet traditionally, you would have had to worry about all of the infrastructure necessary to provide that service. And there's kind of a lot of headaches with that. Servers, networks, firewalls, load balancing, operating systems. How do you scale it? What are the choices you make that are right for a small scale when you're busy developing it, or you're busy rolling out your initial versions to your customers right in the beginning, are almost completely different to the choices you'll make in a year's time as you scale, and in no relation to what they'll be like in 10 years' time when you reach market saturation. So you end up, you're necessarily in a position where you're having to chase this moving target in terms of your infrastructure. High availability is essential if you're providing any sort of vital product or service, but that's complex and ends up being a point of failure itself. Deployment, monitoring and alerting, patches to the operating system, backups, access control, none of these are the problem you're out to solve or the service you're providing. They're all just necessary infrastructure to do that. Serverless is really just a buzzword for making this someone else's problem. And that's quite a powerful thing, because you then spend your effort, your energy and your resources on developing the product that makes you, that you're out to provide, that makes you competitive in the marketplace. So this is the website that I built software for, and I'm going to sort of frame what this discussion in context of a use case, a motivating use case for why we went down this road and why it was the right match for this particular problem. We sell things. We have shop owners who have shops and list items. We don't sell products. These things don't have GTINs. We have a product catalog of currently for sale roughly 500,000 unique items, each of which has images. Images are super important to selling things over the internet. People want to see what they're looking to buy. They want as many pictures as possible, high resolution pictures as possible. So we have in the tens of millions of images. Each one of these images will need to be in various sizes. People want a full resolution image that they can zoom in to see the little nick on the corner of this thing to evaluate whether that's damage that they're willing to live with. So each image will have, on average, about 5.5 photos, each of which will have, on average, about 6 different sizes generated. So we end up with an enormous number of images stored on S3. And as the site evolves, we come up with new requirements to add new sizes to that list because Apple decided that pixel density is a thing. So you need to serve a native or a 1x version, a 2x version, a 3x version, or your site looks terrible on high resolution displays. You've just tripled the number of images you need to store and produce. And it's an intractable problem to go and convert your existing tens of millions of images on S3. It just listing all of those takes over a week with a highly threaded thing hitting S3 until it tells you to please slow down. So we introduced a dynamic image serving system which serves up images as you look at them based on the original, resizes it and returns it to you. We actually spend 2/3 of our processing power doing that alone. But there's another problem in that cell phones now have great cameras, but they produce huge images. 12 or 14 megapixel images are very normal for a cell phone these days. So that's the rectangular grid of pixels is very large. Each of those has 3 color channels, or 4 if we're working with transparency. That's a whole lot of data to process if you're doing that in real time to answer a user's request. So we want something that scales to a reasonable size, a few thousand pixels on an edge, and compressed reasonably so we're not fetching 20 meg images from S3 to even start our rescaling. We tried when we have an image uploader that's reasonably sophisticated because it's such a core part of our infrastructure, our product offering. And we allow people to drag images onto this to upload them, but nothing stops the user. And we actually intend this to be a good way to do it. They can select their entire photo folder of 200 images and drop it onto the web page. But those are large, and we don't want to store them in that format on S3. So we attempted, first of all, to make it the browser's problem. There's kind of a lot more compute on your users' desktops than there are on your servers. Using JavaScript libraries to reprocess and scale them with sufficient quality was way too slow. It took minutes to upload. Doing it on our servers was much too slow as well. We just don't have that sort of compute available, or it's prohibitively expensive to do because the load goes from nothing at that moment to 200 images, all of which are really expensive to process. So you would need to build your capacity out to handle enormous levels of concurrency when you're using that only 1% of the time. So we settled on this approach and you'll see why that makes everything work beautifully. Or we hope. So this is the portion of serverless that we're talking about. Serverless covers other things like database engines that automatically scale, anything where you're not taking care of these concerns. You're not even thinking about which services are running on, what operating system am I running on, where is it running. So in the AWS Lambda model, essentially what you're doing is you're providing a callback that executes in response to some event happening and can do things. And all you provide is your code that actually implements your service. So here I've got a proc handler. It takes two arguments, event and context, which are JavaScript JSON objects. Event pretty much describes what happened. So here we have examples of events. For instance, perhaps the load balancer, the Amazon load balancer hit. So you configured your load balancer to say, for this URL path, I want you to invoke my Lambda. When it matches that, it fires up your Lambda and calls your handler with an event identifying the HTTP hit. It's the responsibility of the Lambda then to return a bit of JSON, signaling back to the load balancer, this is my HTTP response code, this is my response data, these are headers and things like that. Or it could be a key was created on S3, and Amazon automatically, you can listen for that event, you fire up and can take action. API gateway request, that would be something like you're providing a JSON REST API to your customers to be able to programmatically integrate with you. And really just about any other event that you can think about that involves the AWS infrastructure. AWS is Amazon's web cloud infrastructure. The Lambda code itself can talk to really any of the AWS services. So S3 for key value, like bulk key value storage, images, large files, you can put gigabytes on there, it's just fine. CloudWatch, which is really like a logging aggregator and reporting system. DynamoDB, which is a key value store that scales fairly large, is multi-region replicated and things like that. Aurora is their hacks of MySQL and Postgres type relational databases, which also have a complete serverless option. So you just say, I want this database. You scale from 0 compute units to really as many as you need. And as your load changes, it will bring online more compute units and retire them after a period of low load. SQS is a message queuing service, so you can use this to plug together workflows, complex workflows and things. But I'm not really leaving anything out. This is it. This is what you provide in a Lambda implementation, more or less. So if we look a little bit closer, we're zooming now into this middle block of Lambda. This is the sort of the internal anatomy of what's going on. So you have some language runtime and a Bootstrap executable. The Bootstrap's executable's responsibility is to connect to a local HTTP server. That's how the Lambda service communicates with your function and runs things and gets results back. This really connects on an HTTP port based on environment variables it sees, and it does things like get runtime invocation next, and that'll retrieve the next request that it's asking you to run, and you respond back with response or error. There are nuances, but that's the essence of the communication, the loop. So this sits in a loop doing this, and when it gets a request, it calls into your handler, gets the result, and sends it back. So what AWS Lambda is doing, you provided this sort of bundle of things. When it gets a request, it will fire up an instance of this to handle the request and keep it running for a little while. So if another request arrives while it's still hot, this request, you get indication next complete or returns, you process that and return back the result. That's great if you've just got one Lambda, but you very often have a lot of these, and libraries and shared code, you want that common across many of the different handlers. So the facility for that is you have this idea of a layer. A layer is just a zip file, which contains some collection of files. In spinning up your instance of the Lambda handler, AWS just unzips each of these in sequence and overlays them on top of each other in the file system. It's really just that simple. There's nothing. These are just vanilla zips that you send it and it unzips them into /opt. It's just that. So if we look at what's inside one of these layers, for instance, so here is a layer that I use to provide access to the handler code to talk to S3, to AWS services, S3 in this case. So I just have lib tdom, I've got hash for doing some hashes, and on a Tcl'8 site Tcl, I've got a bunch of TMs, one of which is the S3 client that I wrote. Another one, the Pixel library, which does all my scaling and loading and saving and converting and encoding. And then you select a language runtime, and they give you a host of choices. The usual, Node.js for JavaScript, Python, Go, a few others. Inexplicably, no Tcl, which is unfortunate because this doesn't work there, and we're stuck. We would be faced with having to take on another language in our environment in order to be able to provide our services. Now, in reality, we all speak JavaScript. We're web developers. A lot of our stuff is in JavaScript, but we would then have to go and pull in different image processing packages than what we're using on the server to do the rescaling. And I like Tcl. So I wanted to make that possible. Fortunately, quite recently, Amazon made it a possibility to create a custom runtime. And that takes the form of just another layer, the same as all the other layers, but that happens to provide a few key things. There's an executable file in the root called Bootstrap, whose job it is to do that. And that ends up being 150 lines of Tcl script. It's pretty short. Their example actually has it in shell script with curl. It's possible to do it with almost nothing. I've got a bin Tcl shell. I've got a lib. This is really just a stripped down Tcl interpreter. I compiled it without debugging and made it as small as possible and cut all the bits I didn't need to actually service. So this runtime layer ends up being about 1.5 megabytes, which is trivial. It also helps your startup time if it's small. And Tcl'8 site Tcl, I included a few TMs, RL HTTP and GC class, which it depends on, for talking to the controlling HTTP server. So this is now kind of zooming in another layer and what it actually looks like to work with this thing. This is on Amazon's web console for managing the services. So here, this is a sort of a high-level view diagram of the configuration. I've selected layers, and these are the layers down here that I have configured for this particular Lambda function, which is the image upload processing function. So you can see I've got Tcl'869, which is that custom runtime base, AWS and Pixel, which we looked at. And you just say add a layer, upload a zip, and you have it. Each of them are versioned. So deployment with something like this, you just upload a new zip and select a version. So you don't automatically just overwrite or change production code when you upload a new version. You go and opt to use that version. And once you save that, the Lambdas are now running on that. Your function itself can also be handled similarly. You just upload a zip file which contains your handler. You select custom runtime, so we're not stuck using Node and things like that. And this is something to just kind of keep in mind when you're deploying these things. There's a little bit of magic going on here. This is a name.name format. The first section is the source file within your the zip that you upload. So this would be an API.tcl that we'd look at, and handler is the proc that it will invoke within that. So it's possible to have a single zip which contains all of your lambdas, and each lambda config on the tool just specifies process upload handler or edit images handler or something like that. Then this is an interesting way that they approach this. Pricing is by how much compute you use, or a multiple of how much compute by how much memory you allocate. So billing is in something called gigabyte seconds. So gigabyte second is if you have a process or a function that's allocated 1 gigabyte and it runs for 1 second, you've used 1 gigabyte second. If it runs for 100 milliseconds, you've used 1/10 of a gigabyte second. So this sets a hard ceiling on the amount of memory that you can use, and this is what you bill for, even if you use 10 megabytes. There's a bit of a subtlety in that the more you throttle the memory, the more you throttle your CPU as well. Because essentially, this is a share of a piece of hardware. So they do throttle you back on compute if you go too low. In our situation, which is very, very heavily compute limited, CPU bound completely, we don't spend meaningful time accessing third-party services. We found a crossover at about 1.5 gig. That was the point at which below that we were going much more slowly, and we ended up actually spending more money. Above that, the scaling was linear. So we picked 2 gig because we wanted headroom so we didn't crash on very large images. And for us, it just means that we complete in slightly less time, and that means better latency for users. You can set a timeout threshold, so something, if your code hangs, it doesn't just sit there costing you money indefinitely. You can set time bounds on how long you're willing to wait for this to complete. You get some quite nice metrics out of the thing, because the one thing is you're handing over control of your production infrastructure. You kind of want to be able to know, is this working? Am I seeing errors? What sort of rates am I seeing? And things like that. This is a high-level view. There are much more detailed views to drill down into it, but you can see the indications are very spiky. So we have a very strong pattern throughout the day of usage that goes up and down as our mainly US audience comes online and starts doing things and goes to sleep. So we would have to, and this is only on average, if you zoom in, it's much spikier than that. So we would have to provision capacity out here all of the time to be able to handle this sort of spiky load. You see, we're on average hitting concurrent executions of about 60 on this sort of bucket averaging. In reality, we get up to about 200 concurrent. And this isn't even breaking a sweat. Unless you take special configuration, your allocated concurrency is 1,000. So it will completely happily spin up 1,000 instances of your Lambda to handle a load spike, and it's immediate. And you do nothing you're not involved at all to reprovision or change your capacity. And this is you can see the average time there. So you can do your costing based on that. It's just that multiplied by the number of executions, and you'll have what you expect to pay. Logging is quite interesting. So if we go right back here, just to put string standard error goes to CloudWatch. So logging is no more complex than that. You're not using some custom library or anything like that. CloudWatch isn't the most fantastic product, but it gets the job done. And you can see there's 2 hits here. If you look at the timestamps, there's 9/1949, 9/24/43. So that was one, and that's the next one there. And you can see here's a little summary that it produces of, this is too small to see, but I'll tell you. The duration was 650 milliseconds. Build duration is 800 milliseconds. It rounds up to the nearest 100 millisecond slot. We've allocated 2 gigs so that we're getting charged for that times that. We actually used 126 megabytes, and our init duration was 84 milliseconds. So that duration is what happens when it's a cold start, when there isn't an instance of your function there ready to handle the request, and AWS Lambda spins up a new version. So this is the time from making that decision to servicing your starting service of your request. We see that normally with this setup from 40 to 80 milliseconds in that sort of range. So the startup of the Tcl interpreter and cold starting this is actually really fast. So cold starts aren't really a concern for us. Some other people using Lambda go to great lengths to ensure that their instances stay hot. They just have a ping running to them because you've got a large node runtime, and the startup time is half a second. It really matters to keep the thing hot. It doesn't with Tcl. Tcl's fast enough that you don't care. You can see the second one has no init duration, but we were processing a much larger image, so that was 3 seconds in that case. Each of these, you can see this is JSON. So if you log as a JSON document, you can, I can't here because it's a screenshot, but I could drop that down and get a pretty printed version of it. I can also apply some SQL type filtering to these. So I can say, select out all the logs where the status was not 200 and the image dimensions were more than this and that, and just get those logs. So what would a serverless application look like, or what could a serverless application look like? Because what I've described is just a plug-in into an existing infrastructure. We're just using it for doing this rescaling of S3 images as users upload them, handled by this Lambda function. So when it gets that, it invokes your Lambda, gives it the event describing the hit CGI style model, and you respond back with a JSON document, and it fulfills the request. Some path handlers in that load balancer for static resources like CSS, JZ, or GZ, images, things like that point to S3. Possibly an API gateway, so you expose your service programmatically to people as a JSON REST service. Very similar to the load balancer where you specify certain endpoints and you say those endpoints are handled by this Lambda function. Cognito, which is their authentication, identity, access management component. That's a little bit too complex for a Hello World example. This is about 3 or 4 days of reading documentation. But once you do, you very nicely get full IAM support, including federation logins with Google and Facebook and all the rest. So you can offer people the login with Google button to your website so they don't have to create an account, which ends up being quite a lead sort of filter in conversion rate. And something like DynamoDB or Aurora Serverless, where you sign up for the service and you create your schema, and that's how much you get involved in database or in data storage. And all of these share the property that you don't specify capacity. Some of them you can specify bounds. With Aurora Serverless, you can specify bounds if you want to make sure you don't spend too much or at the expense of not being able to service your requests. But this setup scales from Hello World really to any scale you could feasibly address without any intervention. You don't make even any configuration changes to do that. All of these are already completely highly available, redundant. So there's a DNS round robin on these load balancers. There's obviously redundant infrastructure to provide all of these other things. So the simple case is already the reliable, highly available, fault-tolerant, scalable case. This roughly costs about $17 a month, this setup. And almost all of that is the load balancer. You notice I said this is HTTPS. Everything has to be HTTPS now. Managing certs is a pain and expensive, unless you go with Let's Encrypt or something like that. One reason, the nice feature of the AWS stack is any cert you use on an AWS service is free. They have their own CA, and they automatically you just say, I want a cert for this, and it's now HTTPS. The renewals are all handled automatically. You can do similar things for domain names. So I've had my domains expire under me a few times, unfortunately, because I get a lot of email and I miss the renewal notices. You can sign up, it's $1 a month, and they will automatically renew the domains and host the DNS and everything like that. So you're really down to configuring a web page and you've got this. In terms of the bit I was focusing on today, the Lambda stuff, that cost would be zero there as a component of that. The way that AWS pricing structure works is most of their services have what's called a free tier, which is some level of usage really aimed at being able to test it as a developer, below which you don't pay anything. Some of it is limited to a year after sign-up, but most of it is indefinite. In the case of Lambda, you have 400,000 gigabyte seconds a month, which is part of the free tier, which is a surprising amount of compute. We could fit our entire use case in that. And even doing real production loads of pretty high volume, we would fit within that. We use Lambda for other things as well, so we do slightly go over that. So in our case, we have 1.2 million invocations of Lambda a month and about 740,000 gigabyte seconds consumed per month. And our Lambda bill is under $6 a month. It's going to be very, very difficult to beat that cost for providing these sort of services as an enterprise ready thing. So the bit that makes Tcl possible to build AWS Lambda things on, we're open sourcing. I mean, really, it's just a carefully constructed zip of the Tcl runtime and the 150 lines bootstrap Tcl. But there's other layers like the AWS API to connect and talk to S3 and things like that. I was meant to have that done already, but we'll soon have that up on our GitHub page. If anyone wants to play with it immediately, I'll just give you the zip. You can upload it and play around with it. I don't know. I think I'm probably over because I always am. How am I?
We've got time for a couple questions.
Sure. Questions?
Are your slides on the stick?
No, because I started writing them at midnight. I'm sorry. It was even worse this year than usual.
So the API gateway in your model serverless applications, is that the sort of stuff that somebody else is supposed to do? Is that helpful?
Yes. So this API gateway is an AWS service.
It's a service.
Yeah. You go, I want the service, and you go through a fairly complex configuration of these are my endpoints, but it's hosted and managed and everything by AWS. You just fill in the blanks.
And they know how to call you Lambda.
Yeah. You just select, it's a Lambda, this is my Lambda function name, and off it goes.
What's the development debugging environment for this like?
Better than I expected. I expected to have this black box that I throw it into and have to do a whole lot of guessing. So the first, thing I turn to in these is just put string standard error and watch the logs.
Yeah.
There's a lag of about 10 seconds before it shows up in these logs, which is a little irritating. There is a command line utility called AWS Logs, third party, it's not an Amazon thing, that you can essentially tail this log on the console. So I'll have a window open tailing that. There is I don't have a screenshot of it here, but they have a thing called X-Ray, I think, where there's an additional API that you have access to from your implementation where you can submit fine-grained timing and timestamps and information from inside a single run of your Lambda. I think that's more intended for those use cases. Mine are too simple to really need that. There isn't anything like a step-through debugger, but I don't use that Tcl anyway. Anything else?
What about the images themselves? How much control do you have over what
Exactly as much as you would in a normal Tcl script. So let's go back. This is unfortunately a little bit small, but if we look at what's going on here, I'm pulling the name, region, and bucket from the JSON event that I'm passed. I get passed these in query string parameters and stage variables. So this tells me where to find it. And I've configured this on the API gateway, which this particular request is coming from. Just to say, because you can have staging and production, obviously. So I need to know if I'm hitting this from my testing environment, it needs to go to the S3 bucket that contains my testing data. I do an S3 get of the key that was referenced in the request, and that just goes out to S3 and pulls back those bytes. It could be anything. I decode them, scale them. Here I've elided the scale proc. I just included that to show there's nothing special, that this is just this is just a Tcl script. It contains a proc called handler. That's the only bit of magic in it. It relates to the name that you declared. I encode it and re-upload it. You can do really anything that Tcl script can do. You can include really anything you want in these zips in terms of third-party libraries, binaries. You could include image magic in there. You could do whatever you like. There is a practical limit on the size of the zip that you want to use with this. I think there is a hard limit, but generally the sort of tasks that you want to get done, it's a lot bigger than you'd need to there. Do you mean perhaps the AMI image?
When you compile your Lambda.
Yes, sorry, I forgot that.
What OS is it compiled?
They're running it on an AMI which is using Amazon Linux, which is based on Red Hat. So it's an RPM-based distro. They publish the AMI, so you can spin up an EC2 instance with that.
So you build it on your EC2.
Yeah. You do have to be very careful because you have exactly zero control over what hardware this is running on, which is important because you can't rely on like SSE4 or something like that. And it's surprisingly easy to contaminate your build with an unintended hardware dependency. So I built the Tcl runtime very carefully to prevent it wanting to pull an AVX2, because then it works most of the time, and then load spills over onto an older generation of hardware, and your Lambda start failing with illegal instruction. So
maybe build it on many Linux.
So you've got a well-defined Linux target to build for, but it's the hardware dependency that's important. So you just make sure you've got no MARCH native or anything in there that you would do if you're normally wanting pixel wrangling to go as fast as possible. That's not a good idea. Thanks.
Great. I'm our last presenter for the technical sessions of the conference. I actually need a couple minutes to get my equipment set up, so if you guys wanted to step out and hit the breakfast that's still going, or make a quick bathroom break, we'll get going in just a minute.
The proof flight presentation.
Yeah, I should have probably asked to go first or something. Or I could have just had a video, which would have been a lot easier. I have done it this time as well. I've also had some exercise in like forensically reproducing.
You brought your lights. Okay.
Remembering how stuff.
My daughter was doing wearables and fashion design, so she got
Yeah, we're.
things a little bit like
Very
this, but
interesting.
not how
I need this for the eyesight too.
not so much with the not with the Raspberry Pi, but with those tiny Arduinos, the sewable Arduinos.
It's a pretty fancy electrical outlet right there.
Yeah.
Have you ever given thought to how we might do something like Fluent interface and Java C++? You don't need level, but you know, process. That's, you know, as an example, I have a diagram drawing package in Java. And so you subclass the diagram class, and it has a number of methods for things like lines. And so you say, I want to run, that method takes starting coordinates. And if you turn a diagram line, it's provided on the diagram.
Sure.
And that diagram line object has additional reference for color.
Yeah, I want to.
Dash. What additional coordinates.
But yeah,
And each of those methods other than the object itself. So I can say, from 1, dot 2, 10, 10, dot
Oh, this is gonna be great.
2, dot color, whatever, dot, chaining them all along. And it draws it. And so you get an object created, you build up all the data in it. You say,
I have to see that I get this. I've got some tape. It doesn't even draw, but there's a, when you're doing it, you're spawning a lot of. Stuff in the parameters.
It's totally gonna work.
Oh,
Okay, remember, that's doing a similar kind of thing, but I'm just talking about something. Another way you might do it is request. You use a command that creates the HTTP and just chain all of the things you want to say on it. It's a Java way of doing what we would often do with options.
Very good.
Where you set a whole bunch of stuff at once, but they don't just need to be configuration methods that do things as well. And so I might have this the object. You can chain them all together and it means you're not repeating the object variable. You can also do the pipeline.
Turn the lights off for them too, huh? Turn the lights off. Probably show up there.
Like, just put this last.
Yeah.
Some fun adventure.
Yeah. My daughter was doing similar things for wearables.
The question is, you know, is there a way to do that?
Yeah, you use it is roughly the same size, even if it has somewhat more power and Linux and an ARM processor.
Yeah. Lights might be on. He could have lights.
so that I can.
Right, that's pretty good.
At my own, that obviously refer to my avow.
Oh, yeah.
Yeah, I did the same kind of thing.
There's also, there's a huge amount of stuff.
Power, it's like food side, or context, so that's right, and easy change for accessibility.
Yeah, but that's a way of taking one option out of the right. Before
Almost. Alongside the HCM.
I can describe a little better.
All right.
You know, in Java, you start with something. And it's just consuming the return value as its object. Suppose I can, I have an object. And after that,
Sounds good. I have a question. Do you know these people mostly aperture authors? Do you know them?
Yeah.
So where?
yeah.
What I hate that.
Have you heard good things about this? So.
The pipe works really well. Actually, what I was thinking was, all at the same object. Letting the objects
All right, I think we're ready. So when you guys are ready, please take your seats. In general, yeah, it is yeah, amazing, completely amazing. I got some. I bought a whole bunch of these now in black, like from Alibaba Express or something cheaper. Same stuff. All right, everybody, please take your seat. Okay, call you to order so that I can talk, but there it is. All right, so I'm presenting today on pilights, doing fancy things with RGB LED strips using Tcl and a Raspberry Pi. The picture, we're going to get a demo in a minute. This is a demo-heavy talk, okay? So first of all, let's talk about these RGB LED strips. They're really crazy. They have LEDs, as you can see here. These are just lit in primary colors, but this is what the strip looks like. You can see I've got a strip taped up around the screen. And so what we have represented here is 2 LEDs. And there's 160 LEDs on the string, and they have strings that have denser LEDs and less dense, and they have strings that have only a single color of LED or ones that are RGB, but all the LEDs have to be the same color. What's cool about this string is each LED can have a different color. And the way it works is it has a 4-wire interface. So you put on ground and 5 volts, and then you send a clock signal. You just pulse the clock signal and you pulse a data signal and zeros and ones on the data. Each LED has 3 channels, red, green, and blue, as you would expect. There's 7 bits of color each, so 21 bits, which is about 2 million colors, theoretically, which is a lot of colors. And what's kind of cool is you send in 24 bits, and that goes into the first LED. Then you send in a second 24 bits, and that LED's data gets sent by the shift through the shift register to the next LED, and to the next LED, and to the next LED. So you write through all the LEDs, like potentially almost unlimited length, just by shifting in this data. You just keep copying data, and it goes across the LEDs. It's something that I think is pretty cool. This line right here is a cut line, and this line like right here is a cut line. So if you were installing these, you know, like we wanted to put them recessed up in these lighting things, you know, we would get to the length that we wanted, and then we would cut it off so we wouldn't have extra pieces. It's pretty kind of crazy, clever stuff. And the even with those chips and all this, I mean, it's one huge flexible integrated circuit. It's IP67 waterproof, which means you can splash water on it, but you can't really put it underwater or anything. And this is like what the reels they come on. If you buy them in a large enough quantity, you can buy them from Adafruit and from SparkFun in quantity, you know, sizes as little as a meter.
What's the width? Like an inch?
But it's less than an inch, I think, about an inch. And there's even it's a standard size because there's little holders for it that you can buy. It's kind of cool. So they can be cut to a specific length. They can be daisy chained to almost unlimited length, but there's practical considerations if you want to update them quickly, but lots of LEDs. Okay, so first I was started out with using the Arduino. The Arduino is a hobby computer. It has an 8-bit processor. It's an open source hardware and software, so anyone can go into business manufacturing these things. How many of you have heard of Arduino? Yeah, like everybody. Okay, and so you messed with Arduino? Okay, great. So you guys are all with me already. 8-bit RISC microprocessor, 12 megahertz. Several different sizes and form factors. Ron was saying his daughter worked with the super tiny size for, what do you call that? The wearables. Yeah, like fashion wearables and stuff. It's got an IDE based on C++, although it mostly just really looks and feels like C most of the time. And there's a flash loader on there. So, you know, a lot of times on these embedded systems, there's like this JTAG thing you have to plug into to program. You don't have to do that. You just plug in with USB and you click download, and it will almost always download the program and then start running it on the board. So pretty natural build and download and run and development cycle, and I'll demonstrate that in a minute. And lots of libraries and a large and active user community. For I don't know what reason, I settled on this one, a little bit larger board, Arduino Mega 2560. Again, it's the same processor at the same speed. That's a surface mount chip, whereas on this previous one, you could pull that chip out. It's the DIP package. And it's got tons of, well, so it's the 8K of RAM. The one I have actually is an older one, and I think it only has 4K, 256K of flash, which is how we program it, 4K of EEPROM, which is kind of cool. You know, you need to keep cycles and counts on a machine or something, like just whatever. You want to store something non-volatile, you can do it with the EEPROM. 54 digital I/O pins, and they're bidirectional, so you can program it, you know, to like power an LED or power some kind of device, or to receive digital inputs. 16 analog inputs, no floating point, and we'll get to that in a minute because that's a problem actually. They were originally $65. Now the official ones are $38.50. Actually, then you can find them for $28.50 on Amazon, and there's tons of clones, and they're like $13. Okay, so I want to talk for a second about SPI, this serial peripheral interface. This is the way that we talk to the strip. It's a synchronous thing that Motorola invented a long time ago for serial communication. According to Wikipedia, primarily used in embedded systems. It's full duplex, it's synchronous, it has transfer rate of hundreds of thousands of bits per second. It's a 4-wire bus, and the pins are called clock, which that's sort of relevant to that. We have to clock the stuff in. There's a master output, there's a master input, and a chip select, and the chip select thing can select multiple devices. We're not using that, and we're not using the input. We're only using the output, but it's a natural candidate for sending data to the LED strips. This is, again, just a real simple diagram. You can see that they plug across, and we don't need to read, like I said. So this is what the, again, like with these products, there's libraries and stuff, so there's a The chip is called LPD8806. There's several different chips, and some of them are painful to work with, and some of them are easy. So the painful ones require super precise timing, and some of them even require like refreshes to keep the thing lit and stuff. This does not require super precise timing, nor does it require refreshes. So it's the easiest to use. So that just reduces complexity. So here we, here's some of the code. Okay, I include the library for SPI. I include the library for the 8806. I define a strip with 160 LEDs, and colors are UINT 32s, but really, as I said, they're 3x7 bits. And so we set pixel colors into the strip, and then we say strip show, and it should show. So here is an example of a wipe. It's called fill to center, and so you can see it's pretty dead simple. We're going to color in from the outside, and we're going to show, and then we're going to wait, and we're going to do more and do more and do more. So the thing to understand, I mentioned those shift registers. Every time this thing does strip.show, it's going to shift in all the registers. So we're not just shifting in from one side to the other. We can shift in hundreds of, well, at least dozens of times a second. With this small strip, we could probably go hundreds of times a second, although you wouldn't be able to see. Did you have a question or something?
You just got our video back from YouTube.
I just what?
You got our video back from YouTube talking about a strip show.
Okay, too bad. All right, and so now I'm going to demo the Arduino, and how I'm going to demo it is I'm going to plug it in. This is the second most tense moment of the talk. The first is coming later, you'll see. Okay, so this is just demos several of these little routines. You can see it transitioning through different colors, and in a minute it's going to do some more stuff. There it goes. So that's a fill from the outside to the center, another fill from the outside to the center. There's like your sort of sign that's walking the LEDs, where the tout can invite you into the strip show. So this would be like an emergency vehicle or something like that. And it's kind of cool. It's you just call a function with the colors that you want as little vectors, and enough of that. But you can see, I mean, this is how these processors do drive all the crazy flashers on police lights and vehicles and emergency vehicles and stuff like that. It's something that you just want to put the power on, have the thing work, never have to screw with. It's a little sort of popcorn thing, and then it gets more intense. And also on these 8-bit processors, and here we're chasing, some bits around, and then now it's just going to cycle through again. All right, so that's the demo. But let's just jump in on the Arduino, and I'll just show you what it looks like to work with. So here's the IDE. Unfortunately, I can't. I can't get the IDE to zoom, but I can just zoom the graphics card. Okay, so we'll just go in here and say, let's see. So on this first thing, we went from these two colors that was. You see where my mouse is, the cursor here. We had red and green combined, and then we had, we had red and green both times here. So we'll just change this. I'll change that to a 0. So we'll have green and blue. So I'll come up here to the top left and hit the check mark. Hopefully that will still compile. It's done compiling, then I just hit upload. And then it should, did I hit upload? I don't think so. I'm not too impressed with that.
It's not seeing
I'm getting a lot of, what?
on the bottom, it's not seeing the processor on the back end of your USB.
Oh, I know what the problem is. Yeah. I'm not actually plugged into the device, so that'll do it every time. Now, I'm going to. Okay, this is the third scariest part of the talk. I'm going to disconnect the 5-volt power from the computer because I'm going to provide it from the USB. So it'll just stop, but the lights will stay lit at whatever state they're at. that works. Nice catch on the thing there. See, I even brought a flashlight so that I can plug into the wrong pens. Here we go, let's try it again. That looks better. Oh, that looks way better. It says uploading. Updating, upload. It says uploading. That's it. Sorry, well, we may give up on this part. It might have worked. I don't like how that right arrow is still lit like that. All right. Well, anyway, normally you just hit the thing and it just goes. So that's the Arduino. And we'll stop this for a minute. And the power supply is unplugged, but it's still going up the capacitance of the power supply. Kind of cool. Okay, so there were a few things about this that kind of sucked pretty quickly, which was how limited the machine is. There's no floating point. If you want to transition from one color to another, you really need to. If you want it to be visually appealing to humans, you need to use the hue, saturation, and luminance color space instead of the red, green, blue color space. And you don't have to use floating point. You can do scaled integers and stuff, but it's like, why am I working so hard to do all this stuff? Also, I wanted to, I just thought it should do more. I wanted to use Tcl as part of my, it is still powered on, isn't it nuts? It's unplugged. So anyway, it'll die soon enough. But yeah, so, you have to be plugged into USB, you have to flash the thing. It is kind of cool that when it just turns on, it does its thing, but if it could be on a machine that was on the internet, and I could compile programs, and I could use Git, and I could do pushes. And so, golly, the Raspberry Pi came out a few years ago, and it was just kind of mind-blowing, the difference, right? The new one's now 1, 2, or 4 gigabytes of RAM. So if it has 4 gigabytes against my 4 kilobyte machine, I have a megabyte per byte, which is a lot better. It's got Wi-Fi, Bluetooth, gigabit Ethernet, 4 USB ports. The newest one has 2 HDMI ports, and it can drive a single HDMI display at quad resolution, which is called 4K, and 60 hertz or 2 at 30 hertz. 30 is not too great, but it looks fantastic on one. It's got a micro SD card slot. It runs Debian Linux, $35 to $55. So the same price as the 8-bit 12 megahertz processor. You get quad core, 1.5 gigahertz with floating point. So there wasn't, there is an SPI bus on the Raspberry Pi. There are system calls in Linux to talk to the SPI bus. There wasn't a Tcl interface. So first I built this Tcl interface called SPI. It's Tcl SPI. You can get it off of GitHub. And here is some example code to open up the SPA device and configure it for the most common read and write mode, which those modes are how the edge triggering and stuff like that works. Everybody just uses mode 0, is my understanding. Set your bits per word, your maximum speed, and then you transmit stuff. And normally everything that you transmit, you also receive. Next then was to write the pilights to actually control lights, And so here's some example code for doing that. There's, so we say here, all right, pilights create, I'm calling this object lights, in LEDs is 160, and I'm creating one vector to store stuff in. Okay, I open the device, and then here's one of those fill functions. I have a start and ending, red, green, and blue, and a delay, and fill the row and write, and then increment and do it again and again and again. And when you do the write, the delay is in microseconds, and that's just a feature of the SPI driver. And then here's a show function, and it will you run that, and it will run the wipe, very similar to what we just saw in C++. So now I mentioned that there was going to be a more scary moment, and that is this moment. Where I'm going to pull the little wires out and plug them into my Raspberry Pi board. So you just have to give me a second.
I suspect you are powering from the USB.
Oh my God, that's right. Good call. We were powering from the USB, which is kind of scary, but we survived it. So So I'm now just gonna move the wires over, like here's the point, here's the Raspberry Pi, it's got a little breadboard, you know, you don't have to use that ultimately, but it's nice when you're experimenting. So the power is easy enough. This is just so that I can see these pin markings and hopefully get it right. Pay no attention to the man behind the curtain, as they said in The Wizard of Oz. So, fortunately though, you know, it's not necessarily destructive to plug stuff into the wrong spot as long as you are extremely unlucky and plug the 5 volts into the 3 volts or into the ground or something like that. So the Mozzie goes into the Mozzie. The clock goes into the clock. And that's amazing that it could power that strip. One of the things you have to kind of pay attention to on the strip is that it can actually use a fair amount of current if you have a ton of lights and you have them on white, you know, at full brightness. So you got to be a little cognizant of how many amps. And, you know, daisy chain power supplies down those chains.
While it was powered from the USB, it looked a bit dimmer.
It was a lot. I kind of can't believe it worked. But yeah, you figured it out. That's cool. One more wire, and then the smoke test, and then we'll keep going. Hopefully, we'll keep going. Sorry, I wish I had someone to do card tricks or something while this was going on. All right, just making really sure that this is right. And we will now plug the strip in and hopefully see the Raspberry Pi power up. Good sign. And here we see the Raspberry Pi is booting. So once again, I didn't destroy the computer during the demo. And then that's our backup. We should be able to get on this via the network. We'll go from there. So thank you for your patience. Read the login prompt. Well, if this doesn't work, what we have that's really cool is we can use the other thing. Although this sucks.
That's your IP change.
I'm sharing the network. Oh, well, we can just see if this has got an IP. And it does.
What is it?
192.168.2.2. That would be my problem. Yay! We're in. Now we're going to hack the matrix. Okay, so here's a program called Cyan, which you'll never guess what it does. And so here we're just using the Cyan function to move the blue pixel back and forth, and you can see it kind of slows down at the end, which I find visually kind of appealing.
So we took the blue pill?
We took the blue pill. This is Cyan 2, so there's one function that's doing Cyan and one is doing 2 times Cyan. One of the things I kind of wanted to multitask with the other thing, and that was hard, but with Tcl, it's really easy, right? Here's another take on that strobe function that it accelerates the strobing and then it'll decelerate to a fade out. That's kind of cool. And then here's some wipes. Now, this is a little close, you know, really in a like in a lobby of a hotel or something like that. It needs to be background, not foreground, right? So, in fact, it wouldn't be some kind of crazy flashing. It would be some maybe long sequences of a color, like somebody would make aesthetic decisions about what this stuff looks like. Somebody better than me. And so you can see it going left to right, inside out, outside in, and whatnot. That's kind of that's a lot closer to a practical configuration. And then I had mentioned the color wheel. So this is a kind of fancy color wheel, and I think you'll see it's just randomly picking colors and then color wheeling through the HSV space to the new colors, and then once in a while it will decide to, you know, roll in a new color. But you can, to me, there's nothing jangly, you know what I mean? Like there's no weird artifacts of red as it moves from some bright green to some dark blue or something like that. So that's kind of cool. So that was pretty good, and I was liking that. That was nice, but I wasn't satisfied. I felt like we needed better tools. So we've got this two-dimensional matrix of pixels. Two-dimensional matrix of pixels. Where have I heard of that before? Oh yeah, images are two-dimensional matrices of pixels. So so how about if we could use images? Like if we could load in PNGs and GIFs and JPEGs and then, you know, just roll them out one row at a time to the thing. Then we could use Photoshop or you know, and make art that does things that specifically work. So we've got the GD drawing library, which is a nice C interface to load and work on these images and manipulate them. And we've got the Tcl'2019 library, which provides a Tcl interface to that. So we want to read in these images. Well, I've only got 160 pixels. Most of the images I'm going to grab are going to be wider than that, but that's cool because there's a resample function that I can use in GD. So this is just some example code. I load an image. I obtain the height of the image. I conform the image by resampling, and then I attach the image from GD and I copy the image into the matrix in GD. And then this would be an example of, so gradient is a method of the stuff where you can say a certain number of steps and where you start in the list. You know, it was basically a movie, like over a period of time as the sun went down, and you just took one line of that raster, you collected one line of the raster from every image, like the same line, right, over the course of hundreds of images. Then you would actually, the lights would kind of, I think, produce sunset. You know, they would cycle through the colors of sunset and slowly become dark. Okay, so you get it. I'll do one more of these. Anyway, all the software is open source. It's on the internet now. You can go grab it, which is kind of cool because sometimes, you know, when like FlightAware, we're trying to put out some cool software, but it's all got all these FlightAware-isms in them. But we don't have any FlightAware-isms in this stuff, so that's pretty cool. All right, so here's the, if you just go to github.com/Lehenbauer, that's a almost spells itself, right? And there are the packages, and you can, if you get those and follow the instructions, you should be able to get everything built. I actually wasn't able to get it working on the Pi 4, the brand new Pi, so I'm going to actually look into that. I think there may have been a problem just getting the bits out of the SPI bus. One thing cool about the Pi 4 also, they they can overload a bunch of the pins. So like a digital I/O pin can also be an analog pin, can also be, whatever. And so it has 6 SPI buses. So I believe that a Raspberry Pi would have no problem driving thousands of these LEDs and refreshing them at a faster rate than humans can perceive. So, I think there's plenty of grunt left in the machine. Okay, that's it. Any questions? Yeah, Brian.
My question. I've seen displays where you have a single array of lights, and then you have a single light on either side, and you toggle the lights on either side, and your eyes will go from one side to the other. And as you move your eyes, it scans across the single array, and you actually see a 2D image.
Oh, wow, awesome. He said that he'd seen a thing where they have a vertical row of pixels and these lights that kind of draw your eyes, so you move your eye back and forth and then it shows you an image. Yeah, and I've seen some stuff where it's like a metronome arm that, and I saw one recently with these spinning things, and that was incredible.
You can also get two-dimensional arrays.
Yeah, exactly. There's
There's
tons of these things, and there's a lot of, Adafruit has a lot of interesting little, like they have little matrices of LEDs that have like 1,000 LEDs. So if you didn't want to have this thing all strewn across your living room, like I've had off and on, you could do that and imagine, or actually push images out there. There's a lot of really cool. I really like beyond just moving packets on the internet. I think it's fun when computers do things. Yeah, Sean.
It's funny because I was about to say, I really want this set up in my living room because my wife decorates for every holiday, and she's got different colored lights for Halloween, Thanksgiving. Exactly.
Yeah, that's right. Yeah, and there's some TVs that have LEDs that put an ambient LED on the background. So it's using like this technology and then an FPGA or something.
There's one in our kitchen for just some background light. So that's being able to.
Yeah, I think it's really fun. I mean, if you like that stuff and you feel like noodling, you get kind of a lot of software developer psychic joy, for relatively small effort, except for the scary stuff where you might blow your stuff up. But again, even if you blow your machine up, you're in it for $35. Peter.
Yeah, when I was in Halibut, we had this computer room and all that cubicle deep underground. It was super alienating. So we basically got a set of lights like this. They were fixed color. They weren't programmable, but they had a mode where they would just segue between different pastel colors. We put them around the top of the window of the computer center, so you only got the computer room, so you only got the indirect light. It really made a huge difference.
So actually, nice lights actually cause the environment to be more pleasant.
Oh, massive.
Yeah, Kevin.
Yeah, the 3D printers I work with, there's a big strip of these around the top of the printer, so that if you've got a whole factory floor full of them, you can see status of the glass. Normally, most of the strip is showing a progress bar.
Hey, what bar?
A progress bar.
Progress. Okay. Sure.
And then there's like a little cluster that's showing this wavy pattern that say you still got gas flow, and another little cluster that's showing quantity of powder remaining.
Yeah, that's great. There was one of the Tcl conferences when I was in Boston. A bunch of us got a tour at MIT at the AI lab and stuff, and they were doing a lot of really interesting stuff with this ambient computing, where these like pinwheels were just spinning, representing something about network traffic. And the idea is, that's what's there, and you kind of don't pay attention to it, but your mind kind of learns, and so it sees the pinwheels spinning like the wrong direction too fast or something. You're like, whoa, what's going on? So I think that kind of stuff is great, and I think there's a lot of like playing along to music. There's spectrum analyzers. You don't even need a spectrum analyzer. You could just actually read the music and do the Fourier transforms and calculate some bends, and then light these things up. Overall amplitude, things like that.
That was actually what my daughter was doing. So she'd have strings of lights that you sew into the clothing, and then the wearable Arduinos are about this big, and we managed to fit a little Fourier transform in there and do frequency decomposition on a microphone that was also sewn in. So the lights would respond.
There you go.
And the frequency.
That's awesome. Yeah, that's really awesome. And I think it's, I'd like to make a, one of those things where you ring the bell, you know, the feat of strength, and just have the lights zip up, and then, you know, got to still hit a real bell though at the top. So, all right, any other questions? Okay, great. Well, thank you very much. I'm really glad that it worked. I was sitting over there before and I was like, you know, I should have shot some video of all this just in case I blow it all up. I could still show up. I think it's really fun to have the physical thing. Okay, so the next up, we're going to talk about the Tcl core team, right? What's the next thing, Andrews?
The town hall.
Town hall.
We're discussing about the conference next year.
Great. Okay, so we're going to talk about the town hall. Let's take a few minute break, and we'll resume with that.
Let's thank FlightAware for doing all the local.
Hey, all right, yeah, thanks. Thank you, Ron. Thank you, FlightAware. Let's also thank Mentor, a Siemens company, for their unending support.
Cliff is listening. If Cliff is listening.
If Cliff is listening, how do you pronounce it?
Numina.
Numina and Cliff Flint. All right, thanks. We'll restart in 10 minutes.
All right. Yeah, we were using the single wire interface with all the nasty timing. But the Arduino libraries fortunately take care of that.
Right.
And you don't have to deal with it. But,
So that was another
I looked at the spec on that and I said, oh man, I'm glad I'm not.
If there was a, like a huge price difference or something, using Arduino, you can do a better job on timing, right? So you can use it as a workflow. You just pump out to it over.
We did a piece like that, actually. We did a piece like that where we used one of the Arduino wires to hook it up as an output to input the other one. We basically used that to say, hey, you do this, you do that. And we were showing a couple of Arduinos coordinated, like a hat or something, quadrants of different colors.
Yeah. I just don't want to do, it's like, just mind blowing what the revenue is. Any other, like, what else, anything like that. But putting those, they make those cell phone chips in the hundreds of millions, and the price gets ridiculous. And, like, I'm done with crappy embedded systems.
What we did is, we have a few devices that have USB interfaces on it. What we'd like to do is put a Raspberry Pi in front of it and make a server and something.
Yeah.
What we ran into for some of the higher speed devices is there's the E3P, and you lose the Raspberry Pi board, there's this big multi-peripheral chip which is basically working USB.
Yeah.
And so that units the full speaker.
Right.
They have
Yeah, on the floor. Yeah, the floor's a big,
I have to look at that again.
big jump in.
Usually, a couple devices just couldn't push, but it was for some of our devices, those are megabyte per second or something.
Oh, yeah. And before it can do it. Yeah. Well, and, you know, like the ones in this rack, 4K monitors. 4K desktop monitors like $400, and they look fantastic. The older ones, you know, they would be lagging, and at times it would just kind of freeze or all those outputting. I'm not saying it's not, it ain't an Intel Xeon or even a Core i7 or anything like that, but there was absolutely. They got the reliability is super good. The Pi 1 used to go up the SD card just and then each pair like that you would mount it remotely. I mean, it just was ridiculous. But they're like, it's still checking on shut down. And it was really very cool because you could tell exactly not always demonstration
just by looking at the whole front of this thing, like seeing the power status, you know, and you can tell what part of the algorithm that was in.
We're going to Raspberry Pi throughout the building.
We did one where It was rendering it.
Very high speed
Half of those.
Yeah, we have 25,000 resident ground stations worldwide, and
It's flashing and then this one's
one of the
flashing.
things that we have a single player TV where you can throw,
The other thing was.
web-based thing
I
that
don't know if you remember
can show you the status of, if you have a fleet of airplanes, it can show you the fleet. If you're in an airport, it can show you traffic around the airport.
And everybody
It's
announced
an idea that we should just give it away.
and it's
Say, hey man, go get a Raspberry Pi, plug it in, point it at this,
This may have
put on this end, make it Chromium and this URL.
very,
Configure through this, that's how it works anyway. You get on and you configure through this URL and then,
well,
so click on
one day
weather,
we
put it
got a
on.
new section, group, we have groups. And
I don't know, I haven't pitched it to,
Yeah.
I haven't pitched it to Daniel because he's, say that it's a really.
It had been a long time since there was a-
Make sure that I understand
We gotta
what I'm
really
offering, you know what I mean?
And so I.
Before I, because he'll push back,
The truth of that.
how does that help?
He said, well, actually.
What's the profit model?
Fair question.
Is that in a ticket, or is that in a ticket or
Yeah.
something?
Yes.
So that's the question. Where would we open?
Yeah, there's core Trinity case, there's Tcl', and there's the ticket tracker. No, that is a console.
Goes on there, then
If you don't find it, ping me in mail after the conference, and I'll show you a link.
So we got, so the company you want to look for is called Foxconn. They make 3D. Is like spinning in a plastic film, but execution is pretty awesome.
Popular on Kickstarter recently.
Yeah, well, no, the Foxconn guys you can buy, but it's very expensive because they're
Yeah, this
targeting
is-
like medical.
Yeah, this is cheaper. It's more like 12 inch. I think it's like $200.
Foxconn, it's money, man. That's pretty cool.
read it into a sidecar device. And that land. The trouble is will it actually, I mean, we got it, I just don't know if it will do it.
This is the one that's popular.
Reading that word,
It's really solid.
They can't be trusted.
Right.
I just can't believe that. Always on.
They have 7 inch and 12 inch.
Yeah.
It's 20, it's 400 for the small one. 2,500 for the big one.
That was the less destructive version.
Yeah, it's real simple. It's just high resolution rectangular.
Lots of LEDs in the line of the room.
This is the line 25 is plugged into the Yeah, by the meter. If you want to buy for hobby, just to experiment, you get a meter for your spark plug. If you showed,
Yeah, and then if you decide if you're sold and you want to do the living room or something.
Yeah, try to look at that.
I mean, you need to
Go,
buy a
you
larger
turn on the
quantity.
machine.
Right, there's a really nice price
for ODT. And you type in a particular address L, that would make it flow to tape.
I just can't, as an old,
And then that would be accepted.
built-in
Another tape, this is the program, which was character address. So you edit your assembly file and write it out.
You know, and all those projects I had to fail, you know, because there wasn't enough memory or enough CPU. Like the source. Detailed project was that they had to run. And so they just underestimated the object.
And then you have to load the
Like less than a factor of 2, right?
So that you could load all your objects.
What's got 32 bytes in it? That's all you got, and you need 6 by data. So,
Yeah, exactly.
one more bit, like the one more, one more battle, one more.
There was in theory an app you could get for the PD11, palette and 11 that would do the editing and assembly in one program.
I beat on,
But
they're also.
we didn't have that.
Incredibly flexible. I mean, I wouldn't go like whipping someone with them or, you know, pinching them, but these are travels, man. And they, no problems so far on this program.
But the idea was you're managing this.
HDMI, it's a laptop display, thicker than a lot of laptops. But it's got the USB-C, DisplayPort, and HDMI, and then you can population. This is the full, this is the 4K. Now that I've got one, it's like, you know, it's like this size. So it's a little bit harder. So,
And if you got one plus 90 meters.
but again, I mean, this is a great deal. I wish the laptops I had a pin, you know, that you could support HDMI. I'm sure there's some exotic, you know, crazy.
It was a fun little
that weigh
thing.
20 pounds and stuff.
At one point, I had
Well,
a
that would be great. Travel with the collection. Yeah, absolutely. We absolutely could do that. Yeah. You have 2 disposable phones or like.
Oh, yeah. Portable, basic thing.
Yeah. Everybody at every developer at Flyware, everybody at Flyware goes to. Even if they have a laptop, they can put the laptop in, but they just lose the laptop. I mean, the science is in, there's no arguing about it. Sorry, let's pull that around. There's no arguing about it, like it's proven, like developers, Microsoft itself, you know, you need to be able to see all the stuff, and as soon as you're having to move that window around, your efficiency goes way down. Well, the other thing is, you know, the IT switch is so much plastic, like in you know, the 1980s, we would get a new computer, you know, for we share with 5 people, we get a new computer every 2 or 3 years. Yeah, they were spending on that program right here about like they're basically $10,000 in 1980 and 20, which is like $30,000 now. And but now my computer
Yeah, I always so technical style. And yeah, figuring out how to do the text format is nice.
Symbian
Added in additional details and this and so on. We always work on this
You mean like an old school, like a televideo type thing? BT100? Well, no, that's but just some crappy PC. Did you ever Tiffany?
I tried to, we tried to tell,
Conversation started, conversation. You're still gonna.
Well, see, then I think at that point, you just have to look for the arbitrage opportunity, right?
Yeah.
Are they publicly traded?
yeah.
This is the form, and, this is just the case, it's a melt, machine. Yeah, I got these 2 things there.
and it's all very sort of, they have options to choose.
There's nothing like being fun.
Not anything you want to do, it's not based on.
That was,
Okay. So you can do something like that.
Yeah.
It applies to
But I'm not gonna do it anyway.
When you want to say something to them.
Yeah,
Whatever you said.
It's got a name, I don't remember what it's
They
called.
would respond.
Well, yeah, these are not the same.
But that was very kind of limited.
I've only had it for 5 days, and I was just kind of real.
Yeah,
That's good. But I bet it is, now that you mention it,
Do more with
you know what?
There was a context that played based on the chronicles of Amber.
You get on the plane, you go to the seat next to you, that thing on there. Then you can drive. No, it's still.
I gotta get something.
All right, well, let's get it going. There better be 2 you can see them. I don't see 2 you. Oh! Oh! Richard, I got it. I think I got it. You just pointed out that the map might be able to power it just blank. Yeah, we're gonna find out. I don't know if we can put out enough power.
The average speed.
Doesn't work out. Hey, it has to do with issues, so that's a good. Hey, you still have your Oh, I can use. So I don't know.
Next screen.
Yes.
Guy from the hotel to see you.
Hi, how are you?
So don't race to get up there. And, but we can do a once over inspection, make sure all parts.
Great. Yeah.
Okay, so we'll have to.
So this is what I'm signing up for.
It was a that was sort of also my.
I'm signing for the community.
If somebody got something.
Okay.
Yeah, so, you know, while we're here.
Well, I'll make sure it's. Okay.
Actually, they should turn a nice profit.
Thank you,
And,
No, I just want to USB-C, Yeah, that will actually.
And I also could log on this maybe.
Yeah, I would, that would be great. Okay.
Maybe.
All right, thank you, Jorge.
Yeah, no, but see,
I was just making sure that it didn't actually end up happening. Like, you know, they were playing.
Steal it. That's cute.
Take it off the,
Steal this one.
take it off the projector. There we go.
Here.
Okay, well, I don't think this is necessary. You can go straight across the USB. And you have to have. You sold it somewhere. Yeah, I don't think. Oh, yeah.
Yeah, no, that's what.
I want to say thank you. I'm not leaving, I'm actually here, but.
There it is.
Right, have to say thank you.
You got it. You got it.
Okay, you got the comment. Actually,
I don't know if I help.
Also, don't they have to say good money you get from this I will want to. Also next year, I don't know. Out of it, something.
That could be good. I can see why it would like it. Yeah, they're gonna renovate, because they kind of need to.
Yeah, I mean, I saw some of the sockets and yeah, also
Yeah. Well, that's great. Well, okay, we need to,
yeah, it's really, you know, I mean, when you're talking about it, I saw
Look at that. It's an external, oh, it's a satellite backup.
You could have put similar to that from my memory stick. Not quarters, but from my.
Oh, well, we'll see, you know, manufacturing challenges are.
Yeah.
That's somebody else's problem. Oh, and as a manufacturer, they will be sure to point out.
No, actually, it's just, it's not a word, but I think it accurately describes it, as others describe it as a shit shop.
Is the hospital still open? No, not in Boston, no. Sean has already cleaned out the house like
Yeah, no, we're not gonna put it down.
Cool. When are you leaving, Richard?
Soonish, I'm on the ride with, Rahman.
To the airport? Today? Yeah, I'm on my way. Yeah. I'm coming out. Plant dinner or something? Let's trade into it, yeah.
It's cold to you? It was.
Okay. Yeah, I have my recording so far. I will send them directly to Christian via mail, snail mail. I think that I filled my 128 gigabyte disk. I currently have a 64 in it. Another fresh empty one.
Until about 7, so what kind of food are you got anything in mind? I don't know about Mexican food. Oh, whatever you like, it has great food.
Right. Sean Sofa said that.
Okay, well, I'll give you some choices. And you can, Sean Sofa said that his room would be okay, if anyone wants to do it. Okay, great. Okay, well, this will be pretty short then.
Yeah, especially given that the audience also seems to be gone.
All right, I'm gonna talk for like 2 seconds. This will be the part of the talk where we talk about the state of Tcl, of the Tcl Community Association. And Andreas and I put our heads together, and we do not know the state of the Tcl Community Association, but we believe that it turned a nice, tidy profit. Small
Okay,
profit.
I don't know what expenses they exactly have,
Right.
but our income was quite nice.
Income was nice, so that's good. Not to be overly boring, but my proposal is that we have the conference in Houston, Texas next year. Can I get a second on that?
Yeah.
All right. And then, so I promised lots of FlightAware people. And then I've got some ideas that are percolating how we can make the conference much larger next year. And among them, contacting lots of people who used to come and inviting them personally. But and there's some other stuff we're working on. So this meeting is going to be pretty short. So everybody's up for that. How about you guys like about this time of year, the early November? Does that?
Maybe not on election day.
Yeah. Not on election day. That's a good point. That's a really good point.
Can't do October.
I'd make some joke about it. Everyone has to vote for Michael Bloomberg, so I'm just kidding. So it's let's see, November 2020. Election day is that week of the 2nd, right? So it's the 3rd is a Tuesday. So is it the first Tuesday in November? Oh, here we can say. I know.
First Tuesday after the first Monday or something?
I'll ask Mother Google. They wouldn't lie to me, would they?
Oh, no.
They could be mistaken.
It depends on your political affiliation.
And they probably know that very well as you do yourself.
They know for sure. They know stuff I don't. They know stuff about me I didn't know. Okay, the 2020 U.S. presidential election is scheduled for Tuesday, November 3rd, 2020. So how does the following week, the week starting on Monday, November 9th, that week, does that work for you, Richard?
Yep, unless it's really depressing.
Well, it ends on.
Then we just gotta make sure we stock up on the booze before.
This will be a great opportunity to,
It ends on
no
Friday.
matter
the
what
13th.
happens. Oh, and it ends on Friday the 13th, so that's great. Great. Well, we'll get started on this.
And that Monday's a holiday, which actually makes it easier for some of us because we're doing it on our own time.
Oh, the Monday the 9th is a holiday?
Veterans Day is
Veterans
the
Day.
Wednesday. Wednesday is Veterans Day,
Wednesday?
the 11th.
But does it, are we up on the 11th then, or on the 9th, or regular people?
Depends who you are.
You government folks and large company folks, maybe. This is awesome. I'm really, really excited. I'm going to make a bold prediction that we will have more than double the number of attendees next year. In fact, I'm going to promise that we will have more than double the number of attendees next year. And then we'll see and fulfill on that. And I invite you all to join me in causing that to happen. So, you know what, I think that's it. I want to thank you guys all for being willing to do this in Houston. And I mean, it really, obviously, Fido can really, you know, bring that shot in. But poor Cyan Ogilvie has to travel, what, about halfway around the world to get here?
I think this is one.
Oh, it's more. You go the long way. That's great. So, Cyan, we are expecting to see you next year. Great. Andreas? We're seeing everyone next year. Everybody's promising to come next year. David, Richard, Shannon, Joe, everyone. Is anyone not coming next year? Do you need to be? Ron's like,
Incentivized.
we'll see. Oh, Ron, just get a Raspberry Pi and some LED strips and.
Bring some fashion with it.
Penciled in or?
That is, at this moment, that is it. We'll ask the hotel and
Penciled in, but yeah.
it's penciled in, and I intend that that'll be it. That really works for us because the National Business Aviation Association is earlier, and we're always working super hard to get ready for that.
Do you think that's going to be good for all these additional attendees you're trying to get to come, given that it's
I
right
think
after
we did
election?
tutorials the first 2 days, and
I think it's, well, I don't want to get too close to Thanksgiving.
Yeah, no, I get it. I'm just asking because,
Yeah.
you know, reminding that, of course, it was Veterans Day and all that.
Yeah, the Veterans Day, but we'll start, I think we'll do the same
Holidays.
schedule, maybe depending on certain things, 1 or 2 days of tutorials, and I intend that we'll have multiple tracks. We'll see. We'll have some movement on that soon. You guys are just, we got to confront our own resignation about, you know, our expectations being low. We want to raise our expectations and raise our results. I've got a guy who knows all about how to raise people's expectations.
Schedule-wise for me, September and October are much better months.
All you guys, what, I'm sorry, what?
Schedule-wise, September and October are much better months than November.
They are.
Yeah, November tends to start being crunch time.
It does get a little crunchy.
It's kind of true, actually, on teaching.
Well, let me see when, let me see when MBAA is.
Is October bad for flight alert?
Yeah.
Although too close to the turn of the federal fiscal year is very bad for Don.
We always have a lot of, stuff that we're releasing then with big partners and stuff, so. Here. So everybody's working really hard. October 6th to 8th, 2020. So really we could go after that. Do you guys like that better? I mean, Brian does.
Yeah, I actually prefer October if it matters, but my say is not very important.
How about the week of October 19th? And then, because, you know, Halloween's like a week later and people have kids and stuff like that. Halloween's on a Saturday, but still, I know there's some people who wouldn't want to miss just because of their families. So how about the week of the 19th? Does everybody like that?
Yeah, that's good.
Okay, let's pencil that in, and I'll get Violet and Ashley to talk to the hotel. I mean, that'll be the main thing if they're available. And if we do, when we exceed our expectations, we'll blow into the next room and then the next room. And then my only concern is that we may have to find a larger venue, and those can be difficult to book. What doesn't work? Oh, it doesn't work for you?
I'll be at another conference.
Correct. That week, you already are scheduled for a conference that week?
Yeah, actually, it's a conference that I run.
How about the week of the 12th, then? 1 week earlier, October? Does that work for you? How about you, Richard?
That's fine. Yeah.
Okay, let's do it. Yeah, I would like Girish to come back again, very much.
Or just bring his group into our group. Make it really.
Yeah, bring your group, bring more. Okay, so we're tentatively October 12th. And we'll get, how do we communicate on the mailing list?
Communicate with whom and
With each other. This is the people who are sitting here right now are kind of the steering committee for the whole process, right? The people who didn't leave when it was time to decide what we're going to do.
So far, communication with some sort of steering committee and so on, that was private mail, basically.
Okay.
Usually initiated by Cliff and basically all the people. You might have seen such mails in the past.
I've seen some mails from Cliff, yeah.
And we could use, I guess, the conference at Tcl Communication blah blah org as a communication medium. It would be a mailing list.
A mailing list?
Fossil has forums now. Fossil has forums now.
Fossil has forums?
Yeah.
Fossil has forums now,
Yes,
I heard.
yes.
Is that a good way for us to coordinate?
I can set one up if you'd like.
Would you?
I will.
That would be awesome.
Andreas, I'll need your help because it needs a mail server on this. It needs an email sender.
I usually haven't done email senders. The one sender which goes, we have one on Core which was done by Steve London.
There's one on Core? I'll put it on Core.Tcl.pk.
Yeah, I have one which I use. Basically, all the email to speakers, offers, the nagging for materials and so on. That is on Core to conference at Tcl Communication.
If I can just call send mail, if I can exec send mail on Core.Tcl.pk and it works, that's all I need.
My stuff simply talks to port 20. I look at the configuration. I talk directly to some TCP port and jam the mail through that as SMTP.
What do you have to do? If I can make a suggestion, don't send from your own IP. You
No.
want to actually be received.
But what I have is, as I said, it is set up by Steve Landers. I talked to some socket where put the mail in, and he has set it up so that it is a proper email sender, which won't be spam.
You're talking about 25 other local hosts, but it's actually, that's a safe tunnel.
Well, yeah, recognized emails.
Yeah, so like a MailChimp or something like that, will you likely to not actually
Right,
receive by anybody?
No, it's like, yeah, the Ticklebugs mailing list works, and that, it goes through that method.
Oh, so the Ticklebugs mailing list is just talking directly to 425 on Core Tickle.tk?
I'm not sure that's correct in the details, I'd have to talk to Steve.
The Ticklebugs mailing list is separate from the conference mailing stuff.
I will
The conference
set up-
mailing stuff is what Steve has set up, and the Ticklebugs thing is, I believe, not going through Steve's stuff.
Okay,
Because it's
so
older.
Steve set that up as well, but.
In worst
yeah,
case,
we don't-
I run mailing lists out of my domain, and that's, I'm happy to share secure shell access.
All right, I've got, you know what, I've got this piece of paper up here. I requested everybody just come up here and put your email address on here, just so that we can communicate until we have something else set up. So there's no necessary side channel you have to hang on to. So before you go, please fill that out. And I'm Karl at flightaware.com. And I actually have gotten really good about email, and I'm rarely, sometimes I'll get a day or two behind is all. And then my EA is violet.diaz at flightaware.com. So if you have asked me something and not gotten a reply, if you hit her, you'll get a reply from me. So this is great. I am super pumped. Everybody, thanks for everything that you did, the stuff that we know you did, and the stuff that we don't know that you did that made a difference.
Let's have another round of applause for Karl.
I'm just glad to do my work.
Okay, this is the first Tcl conference I've been at where we had those blinking lights.
That's right.
I can't remember when I started doing this last conference.
Show something like this.
This,
It is.
we have a
Yeah.